Alright, today we're going to discuss the topic logarithms. So we have an equation there. So this is what we call a logarithmic equation. So this is how this is read. It's read as log base a of b equal to m. Now, if you're familiar with the concept of indices, logarithm should not be a problem to you because you can always move equations from the logarithmic form to the indices form. Now, what's the meaning of this? When we say log base a of b is equal to m, what we're simply saying is what must that base, which is a, be raised to in order to give b? So from here, we're answering the question already by saying that a must be raised to the power m to give what? B. That's simply what I'm saying. So this first equation is what we call the logarithmic form. So it's in the logarithmic form. While this one is what? The index form. So logarithms are the opposite of what? Indices. So when we say log base a of b equal to, and we're asking what must a be raised to in order to give b. So this is the indices form. We're saying a raised to the power m is b. Now to put it in the better context, let's use words, or rather, let's use real digits. Let's say we have log base 10 of 100, and we're asking what is the value of log base 10 of 100. What we're simply asking is what must 10, this base 10, what must it be raised to? 10 raised to power what is 100? That's the question. Simple. 10 raised to power what is 100? Of course, you know that 10 raised to power 2 is 100. So our answer is simply 2. That's what logarithm is. If I have another one, say we have log base 5, or rather log base 25, log base 5 of 25, sorry. What we're simply asking is what must 5 be raised to give 25? Again, 5 must be raised to 2. All right, so that's what logarithm is all about. If you have another one, say log base 3 of 9. Now we can solve this as an equation. We can put it in the index form since you're familiar with index already, with indices already. So you can say this question is again is asking what must 3 be raised to give 9. Of course, you know the answer is 2. But then you can say, okay, let it be equal to x. So you're saying that 3 raised to power x must be equal to 9. Remember, that's what I'm saying. This base here, a, we're saying it must be raised to this m in order to give what? B. So you see, that's the way it goes, just like a cycle. The base will be raised to the answer, which is m, to give the question, which is b. So we're saying that 3 must be raised to the power x in order to give 9. So you can always change the logarithmic form of any equation to the indices form, and then from here you can put it in the same base. You can also, okay, 3 raised to power x is equal to 3 raised to power 2. If the bases are equal, the powers are equal. That means x is equal to 2. So this is the general idea of logarithms. Now, logarithms are always learned in two parts, right? The first part where we will find the logarithm of numbers mostly less than 1, and not thereabout, using what we call the 4-figure table. But for this video, I'm not going to be focusing on that. We're not going to learn how to get logarithms using tables. We're going to learn how to get logarithm of numbers without tables, and therefore we must know the laws of logarithms. So in this video, we're going to focus on the laws of logarithms and basic introduction to what logarithm is all about. So this is about it. This is the basic introduction. This is what logarithm is. You've learned how to convert from the logarithmic form to the index form. Now let's go over the laws of logarithm. Now, if you know your indices, logarithm will be very simple because they are just the opposite. Now, I'm just going to compare two laws. That's one law of indices and one law of logarithms. Then others I won't compare. Remember the multiplication law of indices. If you have a raised to power m times a raised to power n is going to be equal to a raised to power m plus n. So when you have the same base in indices, you add the power. However, in logarithm, if you have log base a of m plus log base a of n. So you see in logarithm now we are adding instead of multiplying. So just like in indices, when we are multiplying, you add the powers. In logarithm, when you're adding, you multiply the powers. So this will be equal to log base a of m times n. This is the law. This is what we call the addition law of logarithms. So this is the first law. Now the second law is subtraction law. So you have log base a of m minus log base a of n. This will be equal to log base a of what? M divided by n. So it's the reverse. When you're subtracting, you do what? You divide. When you're adding, you multiply. The next one is the power law. If you have, say, log base a of m raised to power n, this will be equal to n log base a of m. So in this case, you see that the power is kind of the coefficient here now. So you multiply everything by the power, which is n. So you have n times log base a of m. That's the power law. So just like indices, all you need to do is to internalize the laws, and then everything should be easy. Now, the next one we have is the logarithm of 1. So if you have log base a of 1 is always equal to 0. So the logarithm of 1 is always equal to 0. And it makes sense, right? Because you see in indices, anything raised to power 0 is 1. So remember, if we change this from the logarithmic form to index form, this will be a raised to power 0 to give 1. So that's it. So the logarithm of 1 is always 0. So it's always simple. If you know the laws of indices, just switch it and you get the laws of logarithms. The next one, which is the fifth one, is the logarithm of a number to its own base. So let's say logarithm of base a of a is always going to be equal to 1. If you change this to the index form, you see that it makes sense because a raised to power 1 is still a. A raised to power 1 is equal to a. So anytime you have the logarithm of a number to its own base, the answer is going to be what? 1. The next one is what we call the reciprocal law. If you have, say, the logarithm of base a to x, right? The logarithm of base a of x will be equal to 1 over the logarithm of base x of a. So you see that they are just flipping sides. On this side, the left side of the equation, we have logarithm of base a. Logarithm of base a of x is equal to, when you put the reciprocal, which is 1 over, you switch the sides. So the base a now becomes the number, while the number x becomes the base. This is called the reciprocal law. So the next one is the change of base law. So let's say we have the logarithm of, say, x, logarithm of base x of m, for instance. If you want to change this base from x, you can replace it with any other base of your choice. Let's say logarithm of base a of m divided by logarithm base a of x. So notice what's going on here. We have logarithm to the base x of m equal to, now I want to change this base from base x with any other base. You can introduce a new base, but remember the new base you're introducing must be the same in the numerator and the denominator of the other side. So it becomes a logarithm to the base a of what? This m. So this will go first, divided by logarithm to the base a of x, the original base. So that's what we call the change of base law. Alright, so if you go ahead and internalize all these laws, the questions that should come with logarithm should not be so difficult for you. Just internalize these laws, and that's the main purpose of this video. So just to introduce the concept of logarithms, and then to try to internalize the laws that are associated with logarithms. And then the next part of this video, we're going to solve some problems that are associated with logarithm. So I hope you found the video helpful. If you did, I'd like for you to subscribe to this channel if you haven't, share with your friends, click on the notification bell so you'll always be notified when there's a new video, and then stay tuned for the next part of this video so we can solve some questions. Thank you for joining.